Here we shall explain the concept of the intervals as subsets of R, where R is what? R is the set of all real numbers. Set of all real numbers. So there can be two kinds of intervals. Two kinds of intervals are there. One is the open interval, and one is the closed interval. Actually, there can be three kinds of intervals. There are three kinds of intervals. One is the open interval, one is the closed interval, and the third one um, is the interval which is closed at one end and open at the other. The interval that is closed at one end and open at the other. Open at the other end. So here let A and B belongs to R. It means A and B are some real numbers and A is less than B. Then the set of real numbers which contains all those elements Y such that Y is greater than A and less than B is called as an open interval. It's called an open interval. This is called as an open interval and is denoted as open interval A comma B. Then the set which contains all those X such that X is greater than or equal to A and less than or equal to B. So in the open interval, the ends are not included. So here the endpoints A and B, ends A and B are excluded. They are not included. Then it is called open interval. And then the set X goes from A to B, where A and B are included, is called as closed interval. It's called as closed interval and is denoted as, and this is denoted as closed interval A to B. So here both the ends are included. Here both the ends A and B, both the ends A and B are included. Then the set which contains all those X, where X is greater than or equal to A and less than B. So here it is called as an open interval from A to B, but here it includes A but excludes B. So this can be written as closed, and so A will be closed and B will be open. Since why B is excluded, here the end A is included. The end A is included, but the end B is excluded. And then the set of all those X such that X is greater than A but less than or equal to B. Here A is excluded but B is included. Therefore, at the end A it will be open, and at the end B it will be closed. So here the end A is excluded, but the end B is included in the interval. So it means that the open interval A to B can be represented as if we draw the number line and we plot the point A, so at the point A and B, I should draw open circle, since why here ends B, A and B are included, and this one I should so in this region, all the real numbers are included from A to B. All real numbers from A to B are included. And suppose we have to show the, so here we can show like this actually. Here these ends are excluded, and this, all the elements from A to B are included. And then closed interval A to B, that can be represented like this. We plot the points A and B on the number line, and both the points are included. Both the points are included. So here we will draw closed circle. So here the circles at the point A and B are open, but here we draw closed circle. It means that A and B are included, and all the real numbers in between A to B are also included. Then if we draw this interval A to B, here and A is open and B is closed. So this can be shown like this, and A is open, and at the B and B it is closed. So at the end B I should draw a closed circle, and at the end A I should draw an open circle. Then end A is closed and end B is open. Then we draw like this. Okay. So suppose, for example, so here the length of each of the intervals. So here B minus A is the length of all these intervals. B minus A is the length of all these intervals, which are open interval A to B or closed interval A to B, etc. Hence A, B, and closed A and B is open. Okay, so all these. Then, for example, suppose if it is asked to write the set in the set X, where X belongs to R, such that X is greater than or equal to -5 but less than 7. If it is asked to write in the interval form, then it is written as closed -5 and 7 is open. Then suppose it is asked to write the interval -3 to 5 in the set builder form. So here this set is written in set builder form, and then it is being converted to the interval form. So now we can convert from the interval form to the set builder form. So this set can be written in the set builder form as X, such that X belongs to R and X is greater than -3 and less than or equal to 5. Okay, so this is the answer. So hope you have understood the concept of the intervals as subsets of R. Thank you.